Hello and welcome to TelecomTV. I'm Martyn Warwick and I'm talking with Jacquenet of Orange. Christian, thanks for talking to us. We're going to be talking about SDN in relation to network traffic management. I'd like to ask you to begin with, how can telcos utilise SDN to respond to the ever-increasing data traffic that is flooding across their networks?
Well, the SDN techniques are made to help us introduce a high level of automation in the overall service delivery process. This means in particular that it will take less time to actually provision the resources which are required by our customers whenever they subscribe to a given service. So from that standpoint, the ability to dynamically allocate the appropriate resources which will accommodate the ever-growing amount of data traffic which will be forwarded throughout networking infrastructures by means of using these dynamic resource allocation techniques, which are part of the, I would say, the functional blocks of the SDN architecture, are really promising techniques so that we can better accommodate our customers' requirements, possibly in real time, depending on the nature of the service itself, depending on the way the service will be actually structured. And at the end of the day, this will be a definite optimization for our customers to access the services they have subscribed to.
So how can they deploy SDN in the optical transport layer?
The interaction between the IP layer and the optical transport is probably one of the key areas where SDN techniques can be applied. Not entering into too much technical details, we are currently investigating the use of the path computation element protocol as a means to convey configuration information between an IP-based control plane and the optical devices for the sake of optical path computation. And this means, at the end of the day, the ability to dynamically allocate optical resources, which again will be capable of accommodating the increase of traffic, especially in the access infrastructures.
And how do they effect more efficient traffic steering across the network?
Part of the functional blocks of the SDN architecture consist in being able to dynamically enforce a set of policies, not only typical forwarding or routing policies, but also traffic engineering policies. And the way you will actually compute traffic engineered paths whose characteristics will be able to take into account the quality of service requirements that may have been expressed by the customers or the robustness of the path itself is clearly a major step forwards for us telecom operators, because we will be able at last to finally accommodate the quality of service requirements, the security requirements by means of dynamically computing traffic engineered paths thanks to a set of SDN techniques.
And a final question to you, how does virtualization at the edge of the network help?
The amount of services that we provide today is pretty broad and pretty complex from a design standpoint. This means in particular that the functional evolution of the CPE devices that we provide to our customers has become increasingly complex over the years. And the ability to actually virtualize some of the capabilities which are currently supported by these CPE devices and to, if you will, store them in the access infrastructure will help us in being more flexible in the actual service provisioning procedures. So these virtualization techniques for some of these capabilities that are currently supported in hardware, possibly by our CPE devices, will help us in actually accommodating the quality of service requirements from our customers in a more efficient way. This is where we see an interest for virtualizing and using virtualization techniques in the access infrastructures.
Jacquenet, thank you.
Thank you.